welcome to episode 10 of the Game Developers Refuge podcast for Monday, July 7th, 2008. I'm your host, Jay, and with me today I've got Kenny.
Hey, guys.
And Mike.
Hi.
Alright, our first topic today is going to be what each of our favorite programming trick, hack, paradigm, whatever it may be, is. Pretty much just our favorite thing to use while developing, and Kenny's going to start us off with that one.
You know, I'm not really much of a good programmer, to be perfectly honest, so I like to build on the work that I've done before. So what I do in all of my games is I have a standard set of what I call behaviors, and behaviors basically govern the behavior of any type of an object in the game, whether it's a bullet or if it's a sprite or if it's a menu or a timer or something like that. Pretty much what I try to do when I write a behavior is I try to make it fit into a standard object structure that I defined I don't know how many years ago, and it really keeps bloating because I just keep adding stuff to it instead of refining it, but that's how this sort of stuff works. For example, you can stack behaviors on top of each other, so if you had a text window, for example, and you had a pointer that was floating somewhere in the middle of the text window, you could have a floating behavior and then specify some parameters for it, and then at that point it becomes autonomous. It floats, it does exactly what you tell it to do based on its behavior. If you have some other behavior for movement or something for, fading in or out or rotation or whatnot, you can set your parameters and just have everything work that way. I try to make it permeate every aspect of the program that I can so that I can reuse behaviors. And as I move on to the next project, I take all my existing behaviors with me so I don't really have to reinvent as much of the wheel as I used to. It started out, the last demo of Phoenix Blade, I had something like 40 or 50 behaviors, and now I'm up to something like 100. Some of them are really, stupidly specific, like for handling palette blending and fading and some other, mostly useless crap. And some of them are more general, like handling vectors and so on and so forth. But it's turned out to be extremely useful for my particularly old, probably antiquated and shitty style of programming, but it works. Yeah.
So what does this look like code-wise?
Damn, that's a really good question, considering I haven't looked at code in a while. Really, when I create an object, there's generally either I can go through and just specify the individual variables. I can say, give it an object type, give it a profession, blah, 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 and then fill it in manually. Or I can sometimes have helper code for things that I use all the time. For example, like smoke. I can create an emitter. And then the emitter is just an object that sits there and it spawns these little puffs of smoke at a set interval, which can actually itself be its own behavior. So if I have an object and I want to set a behavior, I can just call a function that says set behavior, and then the parameters are going to be, whatever the object number is based off of wherever it is, whether it be a pointer or an array to a pointer or whatnot, and then the number of the behavior, and then any parameters that need to go along with it, such as its frequency, how often the behavior needs to update, if there's any velocities or vectors or anything like that. And after that, it takes care of itself. Some of the behaviors terminate when they're done. Some of them are perpetual, and they're attached to the object. So when the object dies, well, they die. It's relatively clean.
So are you using C++ or straight C?
I'm actually using straight C.
Because I was wondering, how... Well, I guess in straight C it just makes sense. You just call a function. So I was kind of wondering how it was all structured so that some object type can call, whatever function, and I'm assuming you call this function, you pass the object, and then you pass the behavior type with it, and it links them together, or?
Yeah.
Oh.
Well, what I have in the background tying everything together is there's a, you're familiar with Allegro timers. It's basically like an interrupt or a thread that runs in the background.
Yep.
And it goes through and it checks all the active objects, and it says, okay, do you have a behavior that needs to be interpreted at this time? And then it goes and it says, okay, execute the code based on that behavior and the variables that belong to that object that are relevant. And then it goes through and it updates itself and it says, okay, next, and next, and next. It's very gloriously low tech, but like I said, I wrote this back before I really knew any good C++ programming, and I said, well, shit, it just works. So I'd hate to toss it aside because it's actually really handy. But yeah, it's in C. So you could probably cut the code in a quarter maybe if you went to C++ and used some inheritance and polymorphism and all the other groovy multi-syllabic shit that comes with C++.
Ooh, Perfect, because my programming trick and hack includes polymorphism.
Oh,
Awesome. Yeah, so we'll just jump right into that. So, yeah, my favorite programming, I guess I will call it a paradigm, because I'm sure this is used all over, for all people who use C++, which is pretty much just using polymorphism in conjunction with the standard template library like vectors or lists. I'm fond of vectors, but essentially all it consists of is something that I find that I need to do a lot is using a concrete example. For instance, in a game you will have NPCs and you'll have various types of NPC. One guy who just walks in back and forth, and another guy who probably like goes fishing or something. And you kind of would like to iterate over all of the NPCs that are in the scene, using one single list, as opposed to saying for all the NPC of type 1, go and do all your stuff, and all of the NPC of type 2, go and do all your stuff. So pretty much what I'll do is I'll create a base object, and you just derive both of the NPCs from that base object, and they will just contain code that does their specific stuff. And where this comes in handy is you can create a regular, standard template library vector, and you can create it of the type which is the base class. And using polymorphism goodness, you can just cast types of those which derive from the base class and throw them into the vector. So I could instantiate 10 walking dudes and 10 fishing guys and say, throw them into this vector, which is base type, and then I can just iterate over that vector, and for all of them call their logic function, which is something shared, or the base types can override it. But as long as they all implement the same function, I can just call it for every single object, so I can iterate through one big list of things. Sounds like
cheating.
Sounds like cheating?
Yeah. I mean, I'm using that word in a complimentary fashion, but I'm saying it sounds like you're cheating the system.
It's sort of cheating. I mean, there are downfalls to the whole thing, because at some point you eventually have to determine what type something is if you need to do something specific. For instance, in Neverfall, I'm using this whole deal to handle any type of object in the game that isn't the player. So if you have a crate versus one of the little Florian guys, they're both in this big vector list thing. Well, a vector is different than list. Just a vector. They're all in this vector, and if I want to go and say save them, well, actually, no, not saving. When I want to load them, like I'm loading them from a file, so I have this file that just contains dumps of all the parameters for each object type. When I load them and I want to actually instantiate the object, I need to know which type it is. So when I'm reading through that file, I'll say, okay, what type of object is this? It's a crate. Then I need to call the specific constructor for a crate, because I can't just call the base class. Otherwise, what would I fill in that's specific to a crate? So, at some point in time, you have to make the distinction. But, it's basically...
I'm a little confused. Maybe I'm not following closely enough. But, so you said you basically have a vector that is populated by what in the letter of the law is the base class from which you derive other classes, but in reality you're casting derived classes into that list, but it just interprets in that way.
Yep. So basically, I'm just stuffing pointers into that big vector.
But I would thought, so couldn't you just wouldn't it call the constructor for the derived class, and you wouldn't have to worry about distinguishing between types?
Some of the constructors take specific parameters, etc., just because of how they're set up. But
okay, I was curious, how do the parameters differ?
Because when I'm calling the constructors, the pointers don't exist in the vector. I'm just going through a file that says, for the next thing, what is it? Oh, it's a box. I need to go and call the box constructor specifically to create a box type.
This is like when I load a level, usually, even though I have various objects, generally all I'm loading is position. And so I was just curious what other kind of things you might be loading. You know what I mean?
It's hard to...
Because maybe your Florians have a mood or an attitude.
Yes, they'll have a position. They'll have whether they're happy or sad. Like a crate will have its position and how heavy it is and how hard it is to push it. So essentially what I do is I'm reading through this file and I find my flag that says I have a crate. And then to the crate constructor I say instantiate a new crate, and here's the pointer to the file I'm reading. Go read your values from the current position in that file and go through and, read.
I see what you're saying. I have an idea. Well, okay, go ahead.
Yeah, it'll read the X position, it'll read the Y position, read whatever, and when it's done, the next thing in the loop will say, okay, what object do I have next? I have a Florian. Now, call the constructor, pass it the pointer to the current position in the file, and it'll read all its values. So
I was just kind of thinking if you could use a string-based parameter, then you could have every constructor could just be expecting one extra parameter, like location, and then a string parameter. And the string could obviously vary between different object types, but you wouldn't have to differentiate. You wouldn't have to figure out what object you have, because you could just pass that string to the constructor of the derived class, and then it could parse that string. You know what I mean?
But in order to pass something to a class that derives from a parent, you have to call the constructor on the subclass. You can't
explicitly
from the parent. You can't call, a constructor on something that derives from it because it doesn't know about it. It's the parent.
All right.
Yeah.
I see.
The knowledge is, it depends on how you look at it, but for me, I have the parent at the top, children at the bottom. The knowledge is kind of, the children know about everything that comes before them, but the parents don't know about stuff that comes after them. It's kind of backwards.
That's how it always works, isn't it? Parents never understand.
So yes, that's my favorite paradigm. I use that all the time just to munch stuff into a list and iterate over it. It's fantastic.
That's the cool thing about object-oriented programming is you don't have to use just screwdrivers and hammers and wrenches. I mean, you can have a bowling ball with a cheese grater on it, functionally speaking, if that's what you really need, It may not look right or sound right, but it works.
Tear up the bowling alley.
Exactly.
Mike, what have you got?
Oh, I don't have anything exciting to see you guys. The closest match I could think of is I'm kind of an object-oriented person now, I suppose. I like to separate everything in my game into little classes. For the application itself, I throw it into classes these days. I started doing that when I got into Python, which is where before I started Python, I was a big global variables, who cares, this and that. Whereas now I like to keep it in a class, which is really the same thing, but, you have variables one or the other. But now I guess I have it isolated in its own class. So I have an application class. I have classes for this and that. This is probably the most routine thing ever, so I don't know if it's any kind of hack, trick, or paradigm. That's my thing, I guess. I also try to reuse things like Kenny was talking about, reusing code whenever I can. That's what you're saying, right, Kenny?
Yeah. Do you have your objects sorted anyway? I mean, do you have super objects that reside in a certain class, maybe in the galaxy or something?
Nothing that I could put on my favorites list. On my monkey game right now, I have it kind of set up like that. There's a hierarchy of objects, but that's only one project, so I haven't really made it a favorite act yet, and I haven't even finished that project yet. So
you've got no tricks out of all the stuff that Python offers?
I like to use lists with mixed objects in them.
Yeah, but that's inherent to Python. Come on.
Lambda functions?
I guess, but I don't want to start talking about lambda functions again. All right. I suppose that covers it for our favorite programming tricks, hacks, and paradigms.